You could stand in a wheat field in southern Saskatchewan and not see much in any direction. Maybe a grain elevator way off. This is the part of Canada most people fly over. But a kilometer under your boots is a layer of solid salt that might make this one of the most valuable patches of ground in North America. Most people who know that salt know it for one reason: potash, the fertilizer mineral. Nearly half the world's reserves are down there, and it's made the province rich. But that's not the interesting part. The interesting part is what that salt does. It's the best natural seal on Earth. Nothing gets through it. Not water, not oil, not gas. It's a lid. And right now there's a race to pull something out from under that lid that almost nobody thought you could dig up. Hydrogen, a fuel you can burn that gives off no carbon at all. So why do so many resources keep turning up in the same place? The answer is the lid. Quick version of how the salt got there. Devonian period. Most of Western Canada sat under a warm, shallow inland sea, cut off enough that it couldn't refresh itself. Hot sun, no way to top up, so it evaporated. And evaporating seawater drops its minerals in order. Ordinary salt first, the rarer potassium salts last. That top layer is the potash. This happened over and over, stacking salt on salt, until the whole thing got buried under a couple kilometers of rock and sat there. Geologists call it the Prairie Evaporite. That's the origin. Here's the part that matters. Salt behaves differently from almost every other rock underground. Most rock has pores, tiny spaces that hold water or oil or gas and let it seep through slowly over time. Sandstone leaks, limestone leaks, salt doesn't. Under pressure, it actually flows and reseals itself, closing any crack that tries to open. So a thick salt bed becomes something rare down there, a barrier that genuinely holds permanently. Think about what that means for anything trying to move upward through the rock. Oil and gas are lighter than the water in the rock around them, so over millions of years they migrate up, until they hit something that stops them. A salt bed stops them cold. Whatever's rising gets pinned underneath, and it pools there and stays for millions of years. That single property, salt seals, everything else leaks, does most of the work here. It's what keeps this one stretch of prairie producing so many valuable resources, which starts to look less like luck the longer you sit with it, and more like a lid over a basin, catching whatever floats up and holding it in place until someone drills down and lets it out. The potash was just the first thing we learned to pull out. It's the layer you mine directly. But the more interesting question is what the lid was catching underneath it. In April 1951, a drill crew hit oil near the Saskatchewan-North Dakota border. Within 2 months, speculators had leased up 30 million acres. This was the part that surprised me when I started digging, that the oil and the potash aren't two separate strokes of luck. It's the same story, told twice. They'd found the Williston Basin, a giant bowl of sedimentary rock sitting under southern Saskatchewan, eastern Montana, and the Dakotas. Same basin as the potash, same buried sea, and it turned out to be full of oil and gas. For 50 years, that meant conventional wells. Find a trap, drill into it, pump out what the lid was holding. Then in the late 2000s, the technology changed. Horizontal drilling and fracking cracked open the Basin, a shale layer that had been too tight to produce before. Today, the basin puts out well over 1 million barrels a day. It's one of only a handful of oil fields on the planet that big. And an oil and gas region doesn't just produce oil and gas. It produces people who know how to work underground. Roughnecks, geologists, drilling rigs, seismic crews, pipeline networks. The rules for who owns what a kilometer down. Southern Saskatchewan spent 70 years building all of it. An entire economy organized around understanding this basin and pulling things out of it. And that turns out to matter enormously, because the newest thing people want to pull out of this basin needs exactly that toolkit. And it's a thing almost nobody was even looking for 10 years ago. For a long time, the textbook said hydrogen doesn't collect underground. It's the smallest molecule there is. It slips through rock. It reacts with everything. The assumption was that even if the Earth made hydrogen, it would leak away before it ever pooled into anything worth drilling. Then, in 1987, a water well in a village in Mali struck a gas that turned out to be 98% hydrogen. They eventually hooked it up to an engine. That village has been running on it ever since. Hydrogen straight out of the ground, no factory, and when you burn it, no carbon. That well broke the assumption, and for years hardly anyone noticed. If the Earth was making hydrogen down there and something was holding it in place long enough to collect, then the old rule was wrong. So what holds a leaky gas in place? A really good seal. This is where Saskatchewan's geology gets a second look. The Earth makes natural hydrogen where certain deep rocks react with water, and the Basin has the ingredients for that. What it also has is the best natural sealing rock there is, sitting in thick layers right over the Basin. The same lid that caught the oil and gas could, in principle, be catching hydrogen too. Now I have to be straight with you because this is exactly the kind of story that runs away from the people telling it. Natural hydrogen is real. The science is real. The U.S. Geological Survey put out its first map of where to look for it in 2025, and dozens of companies and $500 million have piled into the hunt. But almost none of that is production. It's exploration. Outside that one field in Mali, there is no natural hydrogen being pulled out of the ground and sold at scale anywhere on Earth. Not one confirmed large commercial field, yet. The wells might come up dry. The hydrogen might be too spread out to be worth it. It might leak faster than anyone can capture it. This is a frontier, and most frontiers don't pan out the way the early excitement says they will. What's genuinely true right now is more modest and interesting. Saskatchewan has the geology worth checking. The rock that could generate hydrogen, the salt that could trap it, and 70 years of drilling expertise sitting right on top, ready to go look. That combination is rare. It's not a guarantee, but it's a good place to hold the lottery ticket. Go back to the salt. A kilometer under the wheat, there's the floor of a sea that dried up long before dinosaurs walked on land. For millions of years, it's just been sitting there, doing one boring thing: sealing. Holding down whatever floated up beneath it. Every era, we come back and find something new caught under that lid. First, the potash, the salt itself, mined straight. Then, the oil and gas the salt had trapped for us. And maybe, if the frontier pans out, a gas nobody thought could even be trapped at all. The wheat was never the whole story. The province that people fly over, the mostly flat place on the map, it's flat because of what's underneath it. A dried sea, and the lid it left behind. Saskatchewan didn't get lucky a bunch of times. It got the lid once, and everything else followed. If you want the bigger picture, how ancient geological basins gave Canada the world's richest uranium and the third largest oil reserves on Earth, that's the video linked here. The world has a structure. Let's keep finding it.